Welcome to our channel Quaint Cosmos. Today we are going to explore a simple science topic. This topic you will get in physics, in chemistry, again in your everyday life. You will get the same topic, same term, not topic, same term. The term is vapor pressure. Yes, what exactly is vapor pressure? This is of great use. Okay. In our everyday life, again in the study of physics and chemistry. So what exactly is vapor pressure? You know vapor. This is known to you. Now suppose there is a closed container. Just imagine there is a closed container and the container is being heated up, and inside the container there is some liquid. Say for example water is there inside the container. So when the container is being heated up, in that case what happens actually, vapor formation takes place inside the container. So over time the amount of vapor increases, but as amount of vapor increases, one more thing happens simultaneously. That thing is condensation. Yes, simultaneously condensation, that process also occurs. Condensation means what? Here condensation means here the already vapor has formed to some extent. So from that vapor, some vapor again condenses back into the liquid. That means that vapor becomes liquid again. So simultaneously both the processes are happening inside the container. I am talking about right now a closed container. Inside the container water is there. Water is taken as the example of a liquid. Any liquid you can take, and the container is being heated up. So formation of water vapor is taking place, as well as condensation of water vapor into liquid is taking place. And rates are different. But over time, if you wait for some time and the rate of heat supply, means time rate of heat supply to the container remains fixed or constant, then what will happen? If you notice carefully, then after some time the rate of vapor formation, means rate of water vapor formation, and the rate of condensation will be the same. This point or this state is known as the equilibrium state. So how water vapor pressure is defined? The pressure of vapor inside the container at this point is known as the vapor pressure. Yes, at this point. Only when equilibrium is already reached, at the point of equilibrium, vapor pressure is defined. Okay. And also one more thing, temperature should be specified. Because for different temperatures, equilibrium point will be different. Okay, so vapor pressures will be different. So temperature must be specified whenever you are talking about vapor pressure. Temperature must be specified. Without mentioning the temperature, just mentioning vapor pressure becomes meaningless. It is highly sensitive to temperature. As temperature increases, vapor pressure also increases. I want to mention once again that vapor pressure is not the pressure of the vapor itself at any point, not at any point. It is defined, this way it is defined, vapor pressure when the equilibrium point is reached. And equilibrium point means what? Rate of water vapor formation, and for any liquid only rate of vapor formation. Okay, and rate of condensation. Rate means here time rate. Okay, time rate of condensation becomes same. So that means vapor pressure depends upon two main things. One is temperature. With increasing temperature, vapor pressure increases. So temperature dependent is there. Okay, means temperature dependency is there. And next point is nature of the liquid. For all the liquids, for a given, say, temperature remains fixed. I am talking about, say, 150 degrees Celsius temperature. So at 150 degrees Celsius temperature, vapor pressure of all the liquids are not same. It depends on the whether the intermolecular forces are weaker or stronger. Depending upon that thing also, vapor pressure depends. Okay. For liquids having weaker intermolecular forces, vapor pressure will be more. And for liquids having higher vapor pressure, for liquids having stronger intermolecular forces, vapor pressure will be comparatively less for a fixed temperature, for a given temperature. So if you can compare between alcohol and water, alcohol is having weaker intermolecular forces as compared to water. Therefore, for any given temperature, the vapor pressure of alcohol will be more than the vapor pressure of water. And the process of boiling starts when the vapor pressure becomes equal to the atmospheric pressure. Now, right now I am talking about open container. In case of open container, when the vapor pressure of the liquid becomes equal to the atmospheric pressure, at that point boiling starts. But in case of closed container, this is not true. Here atmospheric pressure is not required. In this case of a closed container, boiling starts. First of all, there is means you wouldn't notice boiling properly in case of closed containers. Okay, and in that case, one thing happens, that internal pressure, instead of atmospheric pressure, here internal pressure should be mentioned. So here saturation pressure of the liquid at a given temperature should be equal to the internal pressure, and only at that point boiling starts. Okay, and whenever the container is opened, say lid of the container is opened, so in that case you can observe explosive phase change. Yes, explosive phase change means sudden change in phase, you would notice. Okay, anyway, that part, the last part of this discussion, will be discussed in more detail in a separate video. But just keep in your mind that for open system or open container, when atmospheric pressure and vapor pressure are equal, only in that case boiling starts. But in case of closed container, that is not true. There is no role of atmospheric pressure for boiling to start inside a closed container. That thing, the boiling process, starting of the boiling depends on only internal pressure. Anyway, so and if these applications, yes, so many applications are there. I am not talking about here right now applications of this vapor pressure. Anyway, this was all about today's topic. Topic was what? Vapor pressure. Okay. Okay, so this is the end of this video. Thank you for watching this video.